All right, today we're going to be working some homework from lesson 5.2. Just to kind of flash ahead here, this is problem number 28, problem number 52, problem 64, and problem number 78, part B. So we're going to start back here with problem number 28. In the directions in the book for number 28, it does say, graph each function by hand and support your sketch with a calculator graph. Give the domain, the range, and the equation of the asymptotes. Alright, so first of all, if we're going to go ahead and graph this guy, then I'm going to make a little XY chart here. And I may have to use a little space off the side just to go ahead and work out some problems. Just to let you know that when you let X be any numbers from negative up to positive, when you raise this fraction or any number to a negative number, it doesn't mean the answer is negative at all. In fact, all the answers will lie above the x-axis. Every single one of them. You can use your calculator to check. So for instance, when I put in say -2, and I say let's figure out what that's going to be, well, that's 1/4 raised to the -2 power, which is the same as flipping the fraction on the inside and making it 4 and raising it to the positive second power, which turns out to be 16. This answer right here is 16. I'm going to go ahead and do -1, and same thing here. You have 1/4 raised to the -1st power, which is 4 to the +1, because it becomes 1/4 becomes 4 and -1 becomes +1, and that becomes 4. If I choose 0, anything to the 0 power in math is 1. So I don't care if it's 1/4 or it's 4. Anything to the 0 power in math is 1. And I'm going to go ahead and do another one. Let's see, 1/4 to the 1st power is 1/4, which is 0.25. And 2, if you put 2 right up here, then you will have, just so you can see it, you will have 1 squared divided by 4 squared, which is 1/16. So you're seeing these numbers get smaller and smaller, but they never get negative. Never, never, never get negative. So -216 is off my particular graph. I could redraw it myself, but I'm going to use the graph paper that I have, which is, I'm going to go to -1/4 and 0/1 and 1/1/4 and 2/116. As I continue to pick numbers across here, they will barely be above 0. Barely. They'll be riding this x-axis all the way out. So I'm going to go ahead and change colors here just to give you an idea of what this picture looks like. It's coming down. It's curving through these points, and it will never, never, never reach the x-axis. Okay? All right. Since we have a few more questions to answer, let's go ahead and answer the question about the asymptote to the graph. Okay? The asymptote to this graph turns out to be, as this graph gets close, the red graph gets closer and closer to the x-axis but never actually touches it, this is the asymptote to the graph, which is the x-axis, but its equation is a horizontal line, which in this case goes right through 0 for the y-axis, and therefore this line is called y = 0, which is the same as the x-axis. So there's your asymptote. It does ask you for the domain. The domain of this graph, remember, you're looking for all the possible x's you could have. So we're looking left to right here. As this graph moves up, it's also moving to the left, little by little, and it never stops. It goes all the way out to -infinity. As far as moving to the right, this one's a little more obvious. It moves to the right forever, and therefore its domain is +infinity. And then if you go and answer the range, which is your y numbers now, and we're talking about the y values that exist from the very bottom of the graph to the very top of the graph, well, this graph never gets below the x-axis, which is right here at 0. And because it never touches the x-axis, we do have to use a parenthesis to show that 0 is not included, never touches it. But it does go all the way up to +infinity. and therefore this question has been answered. I'm going to go on to problem number 52, which the directions in 52 are very simple. It just says solve each equation. We're going to use the method that we are supposed to get both bases the same on both sides. Right now, the base on the left side is 2/3. And we're going to leave that alone for this problem, and I'm going to be able to change 9 and 4 into bases of 2 and 3. For instance, 9 is also 3 to the second power, and 4 is 2 to the second power. Because they're both raised to the second power, I can take this, and by the way, I'm going to leave the left side the same. I can take this and I can rewrite this as 3/2, because that's the base of each, the numerator and denominator. But since they're both raised to the second power, I can raise the entire fraction to the second power, because this means exactly the same as this up here. I'm noticing that 3/2 is slightly different than 2/3. So you can take either side and do this next step. Doesn't matter which one, but I'll just leave this side the same for now. I'm going to rewrite this fraction over here as 2/3. But in order to do that legally, I have to change the exponent of the fraction from +2 to -2. As soon as I get the base the same on both sides, which I do, 2/3, 2/3, I can cross out bases on both sides, and I can solve what's left. In this case, you have an exponent of x, and that would be equal to -2. Since there's nothing to solve left, this is the answer to the problem. X turned out to be -2, and number 52 is solved. I'm going to move this on to the next question, which is 64, which is the same directions. We have a cube root of 5. Using our rule that says we can write this as a fractional exponent, there is a 1 right here technically, and the cube root of 5 is the same as saying 5, let me back that up, a little error in the board there, 5 to the 1/3 power. 5 to the 1/3 power is the same as the cube root of 5. There's still a negative x out here as its exponent. On the right side, 1/5 is the same as 5 to the -1. Because there is a 1 here for the exponent on the 5, and when I move the 5 up, this exponent of 1 becomes -1. And the exponent on the outside of that is still x plus 2. Okay, I'm going to use our rule that says power to power, you're able to multiply your exponents together. So this is 5 raised to the negative, because you have positive times negative, 1/3 x equals 5 raised to the, and now you're going to take this -1 and you're going to distribute it, because this one has a plus sign. So this is going to be 5 to the -x minus 2. Again, just like the last problem, as soon as you get the bases the same on both sides, you can cross them out, and we can say -1/3 x is equal to -x minus 2. And that means that we're going to have to solve an equation. For instance, you're going to have to get your x's together. I'll add x here and add 1x here. And remember, this is the 1 right here. So if I do 1 and -1/3, that gives us a positive 2/3 x. You can check that in the calculator if you need help with that. And then over here on the other side, the only thing left is -2. Now I'm going to change colors again here just to remind you that if you need to solve for a fraction, the typical way to solve this is multiply by the reciprocal, which would be 3/2. And we're going to do the same thing to this side. Now this, the 3's cancel, the 2's cancel, the only thing left is x. On the right side, it looks like the 2's cancel up and down, and the only thing left is negative times 3, which is -3. Since x is by itself, this problem is solved, and that completes number 64. Now we have one more problem, and that is 78 part B. It does say in number 78 part B that we are to use an appropriate compound interest formula to find the amount that will be in each account given the stated conditions. $35,000 invested at 4.2% annual interest for 3 years compounded quarterly. We are going to use the formula that says A equals P times 1 plus R divided by N, all raised to the N times T. In this case, A stands for the amount of money you'll have after all of this compounding interest has been completed. P is the amount of starting money you will have. And in this case, P is going to be our starting amount of money, which is going to be $35,000. R is your interest rate. Now, remember, R is 4.2%, but you must change that to a decimal, which is 0.042. And N is your compounding. And this time, we're going to compound it quarterly, which means how many times a year? That would be 4 times a year. So I'm going to fill in everything that we have so far. A equals P, which is 35,000, times 1, which stands for 100%, plus the rate, which is 4.2%, which is really 0.042, divided by, try that one more time, divided by N, which N in this case is 4. All of that is being raised to the NT, which is 4 times T. And what is T, which I didn't draw the arrow up here? Time is going to be in years, which in this case is 3. From here on out, we're going to solve all of this just by plugging it into the calculator. Okay, I'm going to go ahead and start mine up. I'm going to go back to the main screen, clear out whatever's in there, and we're going to have 35,000 times 1 plus 0.042 divided by, it was compounding quarterly, so that's 4, divided, or close the parenthesis, raised to the, and it was N, which is 4, times T, which is 3, and that leaves us with a total amount, which was A, $39,673.89. $39,673.80. I'm going to check that one more time just to make sure I wrote that. $673.81 technically. The 5 bumps the 0 up to a 1. So $673.81. $673.81. I'm going to go ahead and back this up. Put a 1 here. This is our money. This is how much money we will have after we invest that $35,000, leave it in the bank for 3 years, compounded quarterly with a 4.2% interest rate. Is going to be a total of $39,673.81. And that completes our homework for lesson 5.2.